Hey Kayla, you wanted a video, so here you go. Have a video about balancing chemical equations. Balancing chemical equations is pretty easy, I guess. I mean, the ideal is really easy. All we want to do is we want to make sure that the elements on either side will match up, right? So here, let's count the nitrogens, let's count the hydrogens, nitrogens, and hydrogens. I like to keep them in the same order so that I can see a pattern of the numbers. And right now we have 2 and 2, right? We have 2 nitrogens and 2 hydrogens. And on this side, we only have 1 nitrogen and 3 hydrogens, right? 3. So that's no good. So how do we put those together? Well, this 3 is odd, and odd numbers are typically kind of bad in balancing chemical equations. So let's try to even it out and put a 2 there. If I have a 2 there, that makes 6 hydrogens. See, 2 times 3 is 6. So I need a 6 over here. I need to make 6 hydrogens here. So I'm going to put a 3 here. That makes it into 6. That's pretty good. Oh, this 2 also makes this into 2 nitrogens. And what do you know? It's now balanced. 2 nitrogens, 6 hydrogens, 2 nitrogens, 6 hydrogens. We're good to go. As you can see, all we're trying to do is we're trying to make the elements match up on either side. We want their numbers to match up. And how we get there, I mean, everyone has their own way. And as you get more experience, you'll get faster at it. So just go through a ton of practice problems. But let's show you some more practice. This one looks a little intimidating, right? But don't let it intimidate you. Again, draw your little line. Which elements do we have? We have aluminum. We have iron. We have oxygen. We have aluminum, we have iron, we have oxygen. Notice that I didn't do aluminum, oxygen, iron, because then I've seen kids kind of confuse themselves when they do that. Keep the order of elements the same, and let's do our counts. 1 aluminum so far, we have 2 irons, right, and we have 3 oxygens, right? And here we have 2 aluminums, we have 1 iron, and we have 3 oxygens. So obviously it's all wonky. Good things though, here, both aluminum and iron are on their own. And when we have single elements like that, that's always very helpful. And it's good to save those guys for last. So let's do this aluminum and this iron. Like let's deal with this guy. So this guy has 2 aluminum. So maybe I should just put a 2 here. It's got 3 oxygens. It's already got 3 oxygens on this side, so 3 and 3 matches up, right? And then this thing has 2 irons, so let's just put a 2 there, and we're done. Let's do our counts. 2 aluminums, 3 oxygens, 2 irons, 2 aluminums, 2 irons, 3 oxygens. 2, 2, 3, 2, 2, 3, right? We're good to go. Hooray, hurrah. Let's keep moving. Another one. For this one, I put this one on here to show you a little trick. So you would put iron, chlorine, sodium, oxygen, hydrogen, right? Iron, chlorine, sodium, oxygen, hydrogen. But there's a little trick here. If you know your polyatomic ions, you can omit these 2. Instead of doing O and H as separate, you can do them together and call it a hydroxide, an OH, an OH. You see that? This is a hydroxide. It's OH minus, by the way, if you remember them. You remember that? You have a list. You have a list of all these polyatomic ions. And that makes things a little bit easier. I have 1 iron, I have 3 chlorines, I have 1 sodium, I have 1 hydroxide. 1 iron, I have 1 chlorine, I have 1 sodium, I have 3 hydroxides. Looks like we're pretty close because the numbers are kind of matched up. We just have to make sure they kind of do their thing. So 3 hydroxides, 1 hydroxide. Because there's 3 here, I think I'm going to put a 3 right there so that it makes it into 3 hydroxides. So 3 there. Now I have 3 sodium, so I'm going to put a 3 here. All right, now I have 3 sodium, that's good. But now I have 3 chlorines. Oh, I already have 3 chlorines. Cool. And then 1 iron, 1 iron. So let's do a count again. 1 iron, 3 chlorines, 3 sodiums, 3 hydroxides. 1, 3, 3, 3. Here, 1 iron, how many chlorines? 3 chlorines, 3 sodiums, 3 hydroxides, and we are all done. All right. The one little trick is I counted the polyatomic ion as one thing instead of counting each element as its own thing. All right. A couple more examples. If you think you got it, turn off the video, and then maybe when you get stuck, I will be doing harder questions for these next few minutes. Ooh, look at this one. This one's crazy. All right. I'm going to do that same trick that I just showed you, where instead of doing all the elements, I'm just going to list the polyatomic ions and some elements. So there's some hydrogens, there's some nitrates, there's some barium, and there's some hydroxides. If you're like, how do you know it's NO3 and OH? Well, you just have to be very familiar with your polyatomic ions. If you're not there, then you just got to do the legwork and do it one element at a time. But it's kind of a mess, right? Keep the same pattern: hydrogens, nitrates, barium, and hydroxides. So let's do some, you know what, I'm going to save the counts till the end. I'm just going to show you how I would normally do it. I have 2 hydroxides here. I have a water here. We could rewrite this as hydrogen, hydroxide. Water is just hydrogen and a hydroxide. So I have 2 hydroxides here and only 1 here. So let's put this as a 2. Boom. Right? That means I have 2 hydrogens now. 2 hydrogens. Okay. All right. 2 hydrogens here, so I need to put a 2 here to make it 2 hydrogens here. And now I have 2 nitrates, and over here, I have 2 nitrates. That's cool. 1 barium, 1 barium. I think I'm done. Let's do a count. 2 hydrogens, 2 nitrates, 1 barium, 2 hydroxides. 2, 2, 1, 2. Here I have 2 hydrogens. I have 2 nitrates. I have 1 barium. I have 2 hydroxides. And we are done. Cool. I hope you're getting it. If you're not, please come see me. We could do a lot of these practice problems together. Oh, this one is a little bit different. This is a combustion reaction. You know that because there's an oxygen, right? Like the oxygen that you feed into your Bunsen burner. And it always makes carbon dioxide and water, right? Think about solar respiration. So these are always concerning carbons, hydrogens, and oxygens. CHO. 1 carbon, 1 carbon. Right, 1 and 1, 4 and 2, that's no good, so let's put a 2 here. Right now it's 4 and 4 now. The oxygens are on 2 different sides, so 2 oxygens and another 2 oxygens. 2 and another 2, so 4 oxygens altogether. So I need to put a 2 here to make it into 4. And I think I'm done. 1, 4, 4. This is 1. This is 4, and we already did this math, but 2 plus another 2 is 4. Okay, I think I have one more problem, maybe not. Oh, one last one. It's a really hairy one, but if you could do this on your own, you know you've kind of gotten real close to mastery, but if not, I can model for you. C, H, and O's, C's, and H's, and O's. And for these guys, I like saving the oxygen last because it's a singleton, and those singletons are really good to save last, right? So I'm just trying to cancel out these hydrogens, and look, there's 5 carbon. That's weird. So yeah, let's try it. So 5 carbons, that's good. We have 12 hydrogens, and this is 2 here, so I'm going to put a 6 here. All right, now I got to add up all of these crazy oxygens. So there's 5 times 2 is 10 oxygens here. 6 times 1 is 6, so that's 16 oxygens. To get to 16 oxygens, there are 2 over here, so I got to put in the number 8. Because 2 times 8 becomes 16. I think I'm done. So this has 5 carbons, 12 hydrogens, and 16 oxygens, right? 5, 12, and 8 times 2 is 16. Over here I have 5, and then 5 times 2 is 10, 6 times 1 is 16. I got 16 oxygens. For hydrogens, 6 times 2 is 12. 5, 12, 16, 5, 12, 16. We are good to go. Kayla, I know this was a very long video, so thank you very much for watching through the whole thing. But you should really thank me for taking my time to make you a video. I know that there wasn't really a lot taught. I just was modeling how to do it. So really, just because you watch this doesn't mean you'll know how to do it. You really have to grind through those problems and just try to figure it out. A couple of tips that I was going through. Go slow. Count your elements on either side. Odd numbers are kind of goofy. Try to get rid of them first. And if you see an element on its own, that's cool. Save those suckers last. I hope that helps, and good luck studying. Bye-bye.